Well, this weekend he made headlines again when he said that the object could actually be on a mission to release, quote, mini probes that could invade Earth. Avi Loeb joins us now. He's head of the Galileo Project, director of Harvard University's Institute for Theory and Computation.
September 5th, 2025. Harvard astrophysicist Dr. Avi Loeb issues a warning. An 11-kilometer interstellar object called 3I/Atlas could release mini-probes, devices so small they might reach Earth unnoticed, appearing as mysterious UAPs in our skies. This isn't science fiction. It's a hypothesis now prompting congressional calls for NASA to monitor the situation. If Loeb is right, humanity faces the first credible test of whether something out there is watching us, and the potential consequences are staggering. But how did we get from one distant object to this moment of planetary vigilance? The answer starts with a discovery few believed possible. The warning lands in public view late September as Dr. Avi Loeb sits across from the host of the Soul Foundation podcast. Voice steady, words chosen with care. He looks straight into the camera and says, "It could either visit us or release some mini probes that arrive to Earth and appear as UAP." The quote ricochets across science forums, news feeds, and social media. For a Harvard astrophysicist to raise the possibility, however remote, of miniaturized probes from an interstellar object, the effect is immediate. News outlets scramble to summarize the facts. 3I/ATLAS, discovered July 1st, 2025, by the ATLAS survey, is now confirmed as only the third interstellar visitor ever recorded. Telescopes worldwide have tracked its approach, with Hubble data showing a nucleus no more than 5.6 kilometers wide, possibly much smaller. The official NASA classification remains comet, but Loeb's words spark a different kind of vigilance. Within hours, the Galileo Project issues its own statement. 3 observatories, Massachusetts, Pennsylvania, Nevada, are already online, equipped to scan the sky for any anomaly that might follow the object's solar flyby on October 29. Their systems are tuned for the unexpected, objects moving too fast, changing direction mid-flight, or appearing where nothing should be. Loeb frames his hypothesis as a call for scientific due diligence, not a prediction. He points to the object's rare chemistry and trajectory, the statistical unlikelihood of its size, and the timing of its closest approach. The public, hearing the phrase mini-probes from a Harvard professor, feels the tension between routine observation and the possibility of something unprecedented. The countdown to October 29th begins, not just for astronomers, but for anyone watching the skies. On July 1st, 2025, the Atlas survey logs a new object cutting across the outer solar system. Within days, astronomers confirm it is not bound by the sun's gravity. Its orbit is hyperbolic, tracing a path from deep interstellar space. The event draws immediate attention, but not just for its rarity. On the books, this is only the third confirmed interstellar visitor, after Oumuamua and 2I/Borisov. The timing is precise. 3I/Atlas will reach perihelion, its closest approach to the Sun, on October 29th. That date is not just a curiosity. For anyone modeling spacecraft maneuvers, perihelion is the moment when a gravity assist is most powerful. It is the window when a probe, if present, could use the sun's pull to change course or deploy smaller craft with minimal energy. Dr. Avi Loeb's involvement is not random. As a tenured Harvard astrophysicist, Loeb has spent decades in mainstream research, leading the Black Hole Initiative and chairing astronomy at Harvard. His willingness to speak publicly about anomalies has not always been welcomed. but his credentials put weight behind his questions. When Loeb calls for monitoring, he is not acting alone or on impulse. The Galileo Project, staffed with physicists and engineers, is operating under the principle that rare events deserve careful, systematic observation. The object's approach has already been catalogued in peer-reviewed journals. NASA's Minor Planet Center updates 3I/Atlas's orbit daily. Hubble's latest imaging puts a hard upper limit on the nucleus size, no more than 5.6 kilometers across, possibly much smaller. The perihelion date is fixed, the window for any unusual activity is known, and the global scientific community has the tools ready. The case for vigilance is not built on headlines or speculation. It is grounded in the fact that, for the first time, astronomers have both advance warning and the means to watch an interstellar object's solar encounter in real time. Spectroscopic data from the James Webb Space Telescope and Gemini South reveal a comet with chemistry unlike any seen before. The coma of 3I/Atlas is dominated by carbon dioxide, with a carbon dioxide to water ratio measured at 8:1, far above the norm for solar system comets. Photometric modeling, cross-checked by Hubble, sets a hard upper limit on the nucleus, no more than 5.6 kilometers in diameter, possibly much smaller. That figure is less than half the size first suspected, but still puts 3I/Atlas among the largest interstellar objects ever observed. The orbit is beyond dispute. Hyperbolic, with an eccentricity over 6, it traces a path from deep interstellar space, not bound to the Sun. The timing of its solar approach, October 29th, aligns with the moment a spacecraft would exploit for a gravity assist, maximizing energy for any maneuver or payload release. These properties, when combined, draw attention. A rare visitor carrying an extreme load of carbon dioxide, arriving at an ideal window for orbital mechanics. Dr. Avi Loeb reads the numbers as signals, not proof. He notes that no previous interstellar comet has shown such a high carbon dioxide content, and that the chance of a natural object this size being ejected from another star system is vanishingly small. Mainstream astronomers counter that, while the chemistry is unusual, it fits within the extremes known from rare solar system comets. They point to the lack of techno-signatures, no radio signals, no spectral lines of manufactured metals. For now, the debate sits on the data, a comet with an origin story that strains probability, but not yet the laws of physics. Galileo's sensor network runs on a simple principle: catch what others miss. 3 observatories, Massachusetts, Pennsylvania, and Nevada, form the backbone. Each site houses a cluster of wide-field optical cameras, tuned to scan the entire sky for fast, faint objects. Their clocks are synchronized to the millisecond. When something flashes across one camera's field, the others check for the same event. If all 3 agree, the system locks on and begins to track. But the real work happens after the sun rises. Every night, each observatory collects terabytes of raw data. Machine learning filters, trained on years of meteor, aircraft, and satellite tracks, sift through the noise. The goal is clear: isolate anything that moves too fast, changes direction abruptly, or appears where nothing should be. Engineers call these anomalous tracks. Over 1 million such events are expected in the coming months. Most explainable: satellites, space junk, rare atmospheric effects. The rest go into a separate queue for deeper analysis. The network's triangulation system measures not just position, but velocity and trajectory in 3 dimensions. If a true anomaly enters the atmosphere, the system can pinpoint its path to within a few hundred meters. All data is time-stamped and archived for cross-checking with military and civilian sensors. Galileo's engineers work in shifts, updating algorithms to cope with solar flare noise and satellite constellations. Their plan is methodical: catalog everything, miss nothing, and let the evidence speak. The hardware is ready. The question is whether the skies will deliver something that can't be explained. On August 1st, 2025, Representative Paulina Luna drafts a formal letter to the NASA administrator. Her request is blunt: allocate $15 million to extend the Juno spacecraft's mission and secure additional monitoring resources for 3I/Atlas as it sweeps past the Sun. Luna chairs the House Oversight Declassification Task Force, a role that brings her into close contact with classified UAP briefings and the growing debate over unexplained aerial phenomena. She frames her request as a low-risk, high-reward investment in scientific vigilance, citing the rare chance to observe an interstellar object in real time. Inside NASA, the proposal sparks debate. Some see an opportunity, others worry about chasing speculation. Luna's staff points to Loeb's Harvard credentials and missed opportunities with previous interstellar visitors. The letter lands in a climate of urgency, giving institutional weight to a scientific effort that, until now, operated mostly on private funding and academic initiative. October 29th arrives with every telescope and sensor trained on 3I/Atlas as it swings around the Sun. At perihelion, the object reaches peak velocity, nearly 40 kilometers per second, skimming just inside Earth's orbit. This is the moment gravity assist physics predicts. If anything aboard intends to change course or deploy, the energy is now. 3 scenarios play out in expert briefings. If 3I/Atlas alters its trajectory in a way no comet should, the debate over artificial origin reignites overnight. If mini-probes separate and head toward Earth, their arrival could mimic the high-speed, high-altitude entries often labeled as UAPs, unidentified anomalous phenomena. Or, if nothing unusual occurs, astronomers still collect a trove of data on an interstellar visitor. For Loeb and his team, the question is open, the outcome uncertain. The world waits, watching for a signal or silence. On July 1st, 2025, astronomers discovered 3I/Atlas, a rare 11-kilometer interstellar object with an unusually high carbon dioxide to water ratio. Dr. Avi Loeb's warning, broadcast on the Soul Foundation podcast, prompted the Galileo Project to activate 3 observatories and prepare for the object's October 29th solar approach. Congressional records confirm Representative Luna's August 1st letter, urging NASA to monitor for possible mini-probe release, citing both scientific opportunity and national interest. Despite extensive preparations, key questions remain. Is 3I/Atlas a natural anomaly, or could it be evidence of advanced technology? No official NASA response or follow-up data has been released to date. What is certain is this: for only the 3rd time in history, scientists can observe an interstellar visitor in real time, with coordinated monitoring and government support. The outcome, whether routine or extraordinary, will be documented, adding crucial evidence to the ongoing search for answers in our skies.